Well, I'm talking about love of Jesus Christ. And I'm talking about peace that Jesus gave. Listen, because He let us life and He took it again, and He gave us a victory. Well, I'm talking about peace. He gave us peace and love. Well, I'm talking about joy.
Good day and welcome to our continuation video on the mensuration 1. Okay, so in this video we are going to be looking at the area and perimeter of what plane shapes or plane figures. Okay, when we say plane figures, they are simply figures that are two-dimensional, vertical and the horizontal, height and base. Okay, so those are some of the shapes. So the shapes we will be looking at we'll look at rectangle. Rectangle is also a plane figure. We'll look at a triangle. Okay, a triangle. Then we can look at a rhombus. So a rhombus, and then a rhombus extension. We can have a parallelogram, in that way, right? Good. Then 4. We can also look at trapezium. Okay, trapezium, and then it goes. Okay, so we will look at the area starts from a rectangle. Now we all know that rectangle is just the let me say a shape with each sides, each corners being at 90 degrees. So you have this shape here. Then we say here is 90, here meets at 90, at 90 and at 90. Then this qualifies to be a rectangle. It's not only the angles that makes it a rectangle, but also in rectangle, the length, which is one of the sides, okay, the longer side is called length. And then the vertical side is called the breadth or the width. So in rectangles, the length is greater than the width. So the length is always greater than the width and the rectangle. So if you have this is the length, and this is also the length, this is the width, and this is also the width. So in rectangles, if you want to find the area of a rectangle, it's simply just the product of the length, which is the longer side, times the vertical side, which is the shorter part, right? And then this one is going to be the length times width, and that is giving you the area. As simple as this. So here I can give you the value for the length, and then the value for width, and ask you for the area. As simple as that. Or any of these values could be given to you and ask you for the other. It's just a matter of change of subject. Okay? Change of subject. Now, if I'm treating rectangle, then I can just proceed to show you another shape of a rectangle. But this time around, that shape will generate a new name. It will not be called rectangle, but it will generate a new name. So, let's say I have a rectangle like this. But this rectangle is special to the extent that this side, which is the length, okay, is the same as this side. We all know that. We establish that from here. And then this side, which is the width, is the same as this side as well. But this particular shape here, the value of the length and then the value of the width are the same. So in other words, all the 4 sides of this particular type of rectangle has what? All its sides being equal. Then when that happens, then we say, oh, then we can no longer call you a rectangle. Because we say for a full rectangle, then one of the sides must be bigger than the other. Okay? But if you're having all the sides being equal, then your name has to be changed from the normal name rectangle to a square. So then this is now called what? A square. Okay, this is now called a square. So the behavior of a rectangle and a square are the same. Just that in a square, all the four sides are equal. So instead of calling this length and this width, they are all lengths. They are all of the same size or the same distance, right? So this length, this is also length, this is also length, and this is also length. Then when you have that situation, then we say you are tackling what? A square. Very well. So in a square, when you want to find the area, just like the same idea with this, length times width, here is also going to be length times width, but the width here is also a length, so length times length. So eventually length times length, and that is going to be length squared. So if you have a square, it needs to start being square. Okay? Very well. So that is going to be the area, and that is the area of this as well. Now when we come to the perimeter, perimeter is simply what? The sum of the distance around a particular figure. So the sum of the total distance around a particular figure. So for this, the distance around it is going to be width plus length plus another width plus another length. So we are starting from here, we will go around this figure and end here. So the perimeter of this is just going to be the width plus the length plus another width plus another length. So we have two lengths, we have two widths. So it's going to be 2L plus 2W. So when you are looking for the area or perimeter of what? A rectangle, then it's just 2 times the length plus 2 times the width. Same way, when you go to its other brother, then we say, okay, starting from here, length plus another length plus another length plus another length. So then the perimeter of this one is going to be length plus length plus length plus another length. So 4 lengths. So in that case, L plus L plus L plus L is going to give me 4L. So when you are looking for the perimeter of a square, it's simply 4L. Right? So this is how simple these shapes are. Rectangle and a square. That is their way of finding the area, and then their what? Perimeter. Okay. Let's go to the next shape, which is a triangle. Go to the next shape, which is what? A triangle. You know, we have 3 types of triangle: isosceles, triangle, scalene, and then right angle triangle. Okay. So if you have right angle triangle, half times this. But if you have the general triangle, so let me just draw the generalized triangle like this. Have this a triangle here. Okay, so we have this triangle here, and so we call from here. So let's name it A, B, C. Okay, so then the line BC will be called the base of this triangle. Okay, the line BC will be called the base of this triangle, and then this is not a height because it's slanted. But when we want to find the area, we need to actually get the vertical height, which is making 90 degrees with the base. So the vertical height. So we will call it the height of the triangle. So whatever is given, you must try and establish the base value and then the value of what? The height. When you get these two, then you can find the area of what? Triangle. Okay. So if you want to determine the area of a triangle, then that is going to be half times the base. The base you have here is BC. Okay? So half times the base times its height. Okay? So half times the base times what? Height. Now the base we are having here is the BC, and then the height here is, let's say, A to D. So AD. So then the area of this triangle here is going to be half times BC times what? AD. As simple as this. Okay? As simple as this. So any triangle you have is going to be half times base times what? The height. Okay. If you want to determine the perimeter, then we first of all determine the value of this base, and then we determine the value of this side here plus what? This side here. So the perimeter of this meter of what? A triangle, is what? AB, that is this side, plus AC plus BC. Okay, let me say plus AC. So this side plus this side, then plus this, so plus BC. So you have AB plus AC plus BC becomes what? The perimeter of a triangle. So you need to establish the value for the AB, you need to establish the value for AC, the value for BC. Summing all those three values is going to give you the perimeter of the triangle. Okay, so basic shape of a triangle is simply this: the area and the perimeter. Fine. Let's proceed to look at another shape, okay, which is the trapezium. Now, if you have a shape like rectangle, okay, but this time around the base of the rectangle is stretched. It's no longer the same as the top. The base of that rectangle is now stretched, okay. Then we say you are having a trapezium. So this is the shape. You have a rectangle. Then we decide to stretch the base. Okay? So if you stretch the base, it will form something like this. So if you want to find the area of a trapezium, then if you want to determine the area of a trapezium, then we have to label this. Let's say A, B, C, and then what? D. Then we have to label this A, B as say A, right? And then the base BC as say B. And then this trapezium will also have a height. And then this will also have a height. Are you okay? So you can have the height and the height. So we call this height the perpendicular height. So finding the area of this trapezium will now be what? Going to be the half times. It's going to be half times this sum of what? The parallel side. So this side and then this side are in parallel. They will never meet. Okay? So sum of the parallel sides, which is A plus B. So A plus B. All these times the height. So when you are looking for the area of a trapezium, then it's half A plus B times the height. Okay, times the height. Now, you can, if in case you've forgotten this, then you can disintegrate the trapezium into three different shapes, which you have already seen. Okay. You see, per the divisions I've made, then I can disintegrate the trapezium into this shape. This one. That is part of it. I can disintegrate this one into like this. And then another one like this. So if I bring all the three together, then I'm having my complete trapezium. When I bring the three together, I'm having my complete trapezium. So what you can do is, when you've forgotten a formula like this, you can just find the area of this triangle here. It's already out. So the height, the base. And then you find the area here, half, and then the base. And this is right angle triangle, so the base is already half for you. Okay. And then this will now form what? A triangle, a rectangle. So you have the length and then what? The width at this point. So you have to do the base times height for this. Then the length times width and base times what? Height. When you sum these three, you should be arriving at the same answer as this. You are okay. So you can do so. So here too, when we want to look at the perimeter, then the perimeter is just the distance around it. Okay, distance around it. Then we have to look at how to find this shape and then this. So when we know here, then the perimeter is just going to be AD plus this and that, AB plus here BC plus what? CD. Okay, so if you want to make it a line, you can just put the magnitude symbol around it. So AD plus AB plus BC plus CD. When you sum all of them, you are going to get a perimeter of the trapezium. Okay, so in our upcoming lectures, we'll be looking at maybe trigonometry, where I will go detail into how to find the length of what? The hypotenuse of this particular small triangle that is there, so that you'll be able to know how to determine these values in case you are not. But if you are given the slanted heights, then all you need to do is to sum them plus the other ones to form what? Your perimeter. So then this gives us the shape of what? The trapezium. Mind you, if you decide to disintegrate the trapezium like this and you are trying to find perimeter, be careful, because you might find the perimeter of this plus the perimeter of this, then plus the perimeter of this. When you do that, you'll be wrong, because the whole shape, these and these are combined, and when they combine, they will not even show in the first place. So it will turn from distance around to maybe distance within two. Okay, so please, when you are finding the perimeter, do not disintegrate the shape of what? The trapezium. Do not disintegrate the shape. Just maintain it as what it is. Okay, so that is for the trapezium. Okay, so let's go to parallelogram. So if you have a parallelogram, let me see, PR. Okay, so this shape here, parallelogram is more like what? A rectangle that has been compressed. You see, if you have a fixed shape with the sides being fixed, okay, it's not malleable, you can't compress it. And you are trying to compress it, it's rather what? Change its shape or change its orientation. That is what happens between a rectangle and then parallelogram. So with this one, it's having this shape, this. So whenever you see this type of shape, where this place is longer than this side here, then we say you are having a parallelogram. So with this one, the sides here are in parallel and they are the same. Okay, so we can call this side 1, and then this is also a side. Then this one here is also in parallel with this. So then you can call this one base, and then this is also the base. Right, so you have base, side for parallelogram. So if you want to find the area, then you can simply say that, okay, then the area of a parallelogram is simply, we can just establish, if you have a slanted height, we don't use that to find the area per whatever we've been doing. So from triangle, you need to find its own vertical height from the trapezium we just saw. You need to find its own height and the rest, right? So same with the parallelogram as well. You must establish what its vertical height. Okay, call this, we'll say H. Establish the vertical height. Then when you have the vertical height, then now you can find the area of this parallelogram. Then when you do that, then we say, oh, okay, then I'll do another shape over here. Then you see that I have cut a bit of this away, and here too I have cut it away. So then what this means is that this is almost looking like a rectangle. Okay, this is almost looking like a rectangle. So then the area is equal to the base, which is B, the base times its perpendicular height, so times the height. So the base times the height. So if you want to use the symbol notation over here, then it's just going to be B times H as the area. Okay. So the area of a parallelogram, and then is going to be B times H. Be careful mentioning this word. Okay. So when you are, after you've been able to get your area, then the next thing is what? Perimeter, right? So perimeter is as simple as what you see. If you start from here, then it's going to be base plus a side plus the second base plus another side. Okay? So just like we were doing for the rectangle. And that's why I'm saying that a rectangle that has been compressed. So it will change this shape that way. So if you have a rectangle compressed. So then the perimeter of this perimeter here is just going to be this. So base plus a side here plus another base plus another side. Right? So then we have two bases in there, so two base, and then two sides in there, so two of the sides. So hence the perimeter of what? A parallelogram is always 2b plus 2s. So whatever value they've given you after the plane, the slanted heights and all that, you just insert it into either of these formulas to find your area and then your perimeter. Now, as we are treating parallelogram, let me introduce you to the very last shape under these plane figures. Okay? If you have a rectangle compressed, then we say, okay, then instead of it coming down, we rather decide to change the shape like this. What if we have a square and we compress a square? When you compress a square, it will do the same thing that the rectangle did. Okay? So now I want to also assume the same shape. The same. So with this one, this side, all the four sides are the same. This one, only two. The two parallel sides that are the same. But with this, because it's a square that has been compressed, and you know square, all the sides are the same. So these two, the same thing is happening. Then when that happens, then we say, oh, then you are no more called parallelogram. You are called what? A rhombus. Okay, so a rhombus is simply a parallelogram that has all its sides what? The same. Okay, it has all its sides the same. So with these two, you could then say this is the base, this is the base, this is the base, and then this is the base. So you have base, 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 base everywhere, right? And they are all in parallel with each other. Okay. So if you want to find the area of this of a rhombus, then we say, okay, you get the diagonal, right? And then get the diagonal of this side as well. Okay. So they are going to form a right angle over here. Do you see that? So then, with this thing forming right angle, then this side and this side will have the same value. So it means that the diagonal is will cut this diagonal into two equal halves. Same way, this side here, then this side here are going to be the same. Now I'm going to cut it into two equal halves. Right. So when you want to find the area of a rhombus, we call this a rhombus. No, so it's an extension of another rhombus. So we call this a rhombus. Then the area of a rhombus, the area of this one, is just the product of the diagonal. So if I give you that the diagonal here is 4 centimeters and here is 2.5 centimeters, then you know that we said that if here is 4, then down is here 2 is also 4. They are the same. And if here is 2.5, here is also 2.5. So the whole diagonal from here to here will be 5. Are you seeing? And then the diagonal from here to here is going to be 8. So if I want to find the area, then it's just going to be 8 times what? 5. That's what we need. So it's just the product of what? The diagonals is going to be the area of the rhombus. So let's say we label this A, B, C, and then D. Then the area here is going to be AC times what? BD. That's the product of the two diagonals. AC times BD. Okay. Then the perimeter is just going to look like that of a square. Okay. It's just the same side. So the perimeter of this one is just going to be AB plus BC plus CD plus BA. So just base plus base plus base plus base. So it's almost like 4 base. Just like in square, it was 4L. In rhombus, it's called 4B. Okay. So we've come to the end of our video on mensuration 1. So in our earlier video, we looked at a part of a circle where we mentioned the sector, the segment, minor, major, sector, major, segment, and all that. So we look at how to find those ones, and then finally finding the area and perimeter of plane figures, which I listed figures down there, and then we looked at how their area and then their perimeters are generated. Okay, so I hope from this point forward, if you are asked to find radius, you are asked to find area, perimeter, length, base, height, and all that, it's just a matter of getting to know which formula and which shape we are talking about. So solving many questions and then consultation from us, the facilitators of this, okay, will help you to grow and expand your capacity in terms of solving particular questions under mensuration 1. Okay, so watch out for our next videos as we tackle other topics, indices and logarithms in mathematics. I know you are going to enjoy it just like we did for this. Okay, so I'm hoping to see you in that video. God bless you.
He gave us peace and love. Well, I'm talking about joy. The joy of the Lord is my strength, because it made me so happy in the Lord. Listen, because it's just not a walls of the vision, and it brought me closer to my God. Yes, it makes me go wow. H-A-P-P-Y, H-A-P-P-Y. Yes, my Lord is so kind, so kind to me, because my Lord is so good, so good. Well,